Epic. Epic! Epic Stat-1 speedruns of statistics! Brian Stevens versus Chapter 10 Sample Surveys. Begin!
Okay, when it comes to sample surveys, we need to use our note cards here. Use Quizlet, flashcards, or something, because this chapter is a lot of memorization. When you have things like a population and a sample, we have here the population is every person or thing we want to understand. So think about, you're at the M&M factory and we're creating M&Ms. The population of M&Ms would be every single M&M we create. Now, when you go out and you take a sample, the first thing you're going to do is have a sample frame. Now, the sample frame, which is later on the sheet here, is everything you have access to. So the sample frame is everything you have access to. So maybe you go in, let's say in February, and you're sampling M&Ms. So only the M&Ms created in February could you possibly sample. I think this is where a lot of the confusion is between a population, sample frame, and sample, because the population is all M&Ms, but the sample frame is the ones we could theoretically sample. So we don't actually take everything in the sample frame unless we're doing a census. More on that in a moment. But with this right here, we are looking at everything we could possibly take, and this is where we will get our sample. The sample will be the observations, or the M&Ms in this instance, that we actually take. Now, they're probably not all red M&Ms, but we're just marking them red here to denote that these are the sample. So just to review these key concepts, the population is every person or thing you want to understand. Our factory makes M&Ms and we want to understand the M&Ms. The sample frame is the things you have access to sample. Since we are going in February, we only have access to the M&Ms made in February. We can't sample ones made at other times because they're not in the factory, so they're outside of our sampling frame. Now we have the actual sample, which are the M&Ms we take. We're not going to take all the M&Ms, at least in this instance that were made in February. There's going to be M&Ms we don't take. Things in the population and in the sample frame we don't take. Now, things outside of our population cannot be observed. We cannot take a sample outside of our sample frame. So these are things outside of our sample frame. They're still M&Ms. We're still interested in them, but we don't have access to taking them. Now, it's important to know here the difference between a parameter and a statistic. Let's say we want to know whether or not our M&Ms are properly made, like they're chipped or something. So we have M&Ms that are properly made is our parameter of interest. So when you look at what a parameter is going to go with population. Parameters are a characteristic, like an idea, like the percent of M&Ms that are properly made, or the percent of M&Ms that are blue, or maybe the average weight of an M&M. This is something that is true for the population. We often think about parameters like maybe the percent of students that are in-state at the University of Tennessee as things that we actually know. Now, sometimes we don't know the parameter, like maybe we'll never know the true proportion of M&Ms that are properly made at our factory, but that might be something we want to understand. And that understanding is obtained from a statistic, which comes from a sample. This is where I always say PPSS. Population parameters are the things we want to understand for everything, where a sample statistic is how we make inferences, and that's why we call it inferential statistics, into the population. So from this sample right here, we will get an estimate of the truth for all the M&Ms, including the ones in the sample. So we want to understand from the sample, we will get a statistic to estimate the truth for the population of all M&Ms. And that truth is a parameter, sometimes called the parameter of interest. And the key word there is just parameter. Now, what we need to think about is how do we get a representative sample? We need to make sure we go at the right time. We need to make sure we have the right sampling techniques to get a representative sample. And what does a representative sample mean? It means that we are getting the key characteristics of the population and not including bias. Bias is kind of the inverse of representative, where we don't have the characteristics we're looking for because maybe we went during the wrong month. You could say, wait, February is when everyone's on their best at the factory, and we're getting a sample that is actually too good, and we're not covering the other months. More in these biases in a moment right here. But we need to make sure we have a representative sample. Now, one thing I do want to mention here, a very important topic we should know that's not on here, is going to be a census. A census is when you take the whole population. So if you take a census, you would actually need, we'll draw it this way, you would actually need access to everything in the population, and then you would take all observations. So everything would be taken. You'd have access to everything, and then you would take everything. So like the US Census, in theory, should take all observations from the population. So you would have access to everything in the population, your sample frame would be everything, and then your sample would be everything, and that is a census. So a census, like the US Census, is when we collect data on everything in the population, hence we'd have access to everything, and then to draw this out correctly, we would then take samples of everything. So if we're drawing this out with the colors right here, we would see that we would take every single observation in the population, and they would all be in our sample. So this is a unique thing right here called a census, when you collect data on everything in the population, and thus we would have access to everything in the population. So what are some bad types of sampling? Bad types of sampling would definitely be things like voluntary bias. Now, voluntary bias is when people are going to be excited, or things, which is hard to understand how a thing would be excited to take a survey. More often we think about people giving voluntary bias. But voluntary bias would be like, I use my classic Pokemon Go survey. If I'm like, hey, who wants to take a Pokemon Go survey? And someone's like, hey, I love Pokemon Go. I mean, who doesn't? So if somebody was wanting to take the survey, then that would be voluntary bias. And the issue with voluntary bias is going to be that people are often going to have stronger views when there's a voluntary bias. So when you have voluntary bias right here, which is not a good type of sampling method, you're going to see these people have stronger views, and they're not going to be representative of the population. Now, when it comes to convenience sampling, this often is how we do our sampling. I think of convenience sampling as going out and taking the first so many observations. So if you went to a line at Walmart during the release of the new console, let's say the new Nintendo console is coming out, we've already got the new PlayStation, and you've got just this line of people out the door. And so you go and you talk to the first 5 people in the line. If you talk to the first 5 people in the line, you might just like walk up, maybe the news station's there, and they're saying, hey, are you excited about the launch of the console? You're like, wow, everyone's so excited. It's like, well, they talked to the first 5 people in the line, the first 5 people they had access to. Is that really representative of everyone in the line? Is that really representative of everyone who's interested in buying the console? We need to make sure, if we want to understand the views of the population, which might be people who play video games, then we need to take a representative sample of people who play video games. And the first 5 people in a line buying a console would not be representative of individuals, all individuals who play video games. So they're kind of going for the easiest people to talk to, and those aren't really the views of the whole population. Now we get to the good types of sampling methods, the ones we should actually do. So we have here simple random sample. With a simple random sample, let's write down the key steps for this. We'll do the steps for each one of these. Simple random sample steps are, let's go ahead and put these here. Simple random sample. 1, everything in the population gets a number. So we'd number all our M&Ms, and then 2, select these numbers randomly. So the way we do a simple random sample is everything in the population gets a number, and just assign numbers to them, like we have student ID numbers. Then we randomly generate these numbers, and this is a true random way to get a random sample. Okay, simple random sample is great. Next, we have stratified. I'm actually going to go to systematic because these are the easier ones for the moment. So let's go to systematic sampling. So when you do systematic sampling, you start at a random. And the reason we do this is because there might be variation in some way with where we start. So we try to make where we start random. So we start at a random starting point, select every kth observation. And what does kth mean? Well, it could be 5th, it could be 8th, it could be 2nd, technically, even though it's kth. But we're just selecting every so many observations. It's like you're watching the M&Ms coming down a line right here, and you say, I'm going to select every 5th M&M and see if it's chipped or not, and just put it in a bag, or put it in a bag for the observers to look at. So every blanked observation will be looked at, and we do this right here and just take our samples systematically. So this is a systematic sample where you just have a system where you select every kth, and usually it would be something like maybe every 20th M&M. Who knows? Just depends on how we choose to set this up. We could go into more detail on other classes on what is a good interval to do your observation in. So now we get to the 2 difficult ones that usually people get confused on. You're like, yes, I want to hear about that cluster and stratified. So let's do cluster first. And when we think about cluster Cluster sampling has the first key aspect. Things are randomly put into clusters. This is probably one of the hardest things to satisfy because we need random assignment to clusters. There's no reason. Like you shouldn't say like this is the blank cluster and this is the blank cluster. In my class, we talk about walking into Krispy Kreme and saying, give me donuts. And they're like, what? And you're like, give me a bunch of donuts. And they're like, what kind? And you're like, just give me donuts. That's what we're talking about right here. They're just going to give you random donuts. Don't distinguish anything difference between the donuts. You walk into the Coca-Cola factory and you say, give me Coca-Cola, a bunch of Coca-Cola at one time. And they say, here's a 12-pack. And you say, thank you. Now, notice I did not say anything about that 12-pack. You say you walk into Domino's, you say, give me a bunch of slices of pizza. And they say, what kind of pizza? You say, I don't want to know what type of pizza. And so it'd be really hard because the slices of pizza, of course, depend on what pizza they come from. But they just give you a box of pizza, which has multiple slices in it. This is a cluster sample right here. Each slice of pizza could be considered its own sample. Maybe you're trying to do a quality control on it, and you're trying to see, do the slices have the right amount of cheese? Are they burnt? All these different things. So you could look at each slice to see the quality of each slice of pizza, and then the pizza is the cluster. So what do we do now that we have things into random clusters, which is a little hard to satisfy? We have here that we go and we randomly take the clusters. And as I always say, perform census on the cluster. After we have our random clusters, we're going to perform a census on the clusters, which means we're going to sample every slice of pizza, which means we're going to drink every can of Coca-Cola. This is an excellent day where we get to eat a full thing of pizza and drink 12-pack of Coca-Cola. But these are cluster samples right here, and we haven't said any difference. We didn't say if it's a pepperoni pizza. We did not say if it's a cheese pizza. We did not say if it's Diet Coke. We're just saying 12-pack of Coke. That's a cluster. So with this right here, I want you to think about what clusters are. Clusters are just taking a whole bunch at once. It does not acknowledge a difference. And that is the key thing we need to think about when we get to stratified here in a second, which is where people usually get confused. Stratified does deal with groups. Stratified sampling. Stratified does deal with groups. Acknowledge a difference in the population. Take your sample randomly with respect to that difference. So we are going to acknowledge a difference in the population. What do I mean by this? There's a difference between diet and regular Coca-Cola. So now we are starting by acknowledging a difference. And then we would say something like our factory makes 80% regular Coca-Cola. So we got 80% regular and we have 20% diet. So 80% regular and 20% diet. With 20% diet, if we take a sample size of 200 observations, so we're going to take a sample of 200 observations, then how many regular cans would we take? 160. How many diet cans would we take? 40. And notice I'm saying cans because right now we're just doing stratified. We're just acknowledging a difference and then sampling in accordance to that difference. Even though these are groups, we're not taking a whole bunch at one time. I know we're taking 160, but that's just 160 individual cans randomly taken from all the regular cans of Coca-Cola. It goes through the same process of a simple random sample. So you're going to enumerate all the cans. This is not multi-stage. You're just randomly taking the cans via simple random sample. So in this example right here, we're acknowledging a difference that our factory makes regular and our factory makes diet. Then we're sampling in accordance to that difference where we're saying, well, then to be representative, if we make 80% regular and 20% diet, we need to take 160 regular cans and 40 diet cans in our sample of 200, lest we undercover or overcover certain groups. So when you stratify, you always start by acknowledging a difference. If you were to acknowledge the differences between majors, you would be stratifying. Like if you say there's a difference between psychology and supply chain, you're stratifying. If you say, let's go into classrooms and let's take classrooms as groups of students, then you are doing cluster sampling. Although classrooms are not randomly put together, it's the hardest one to always do with cluster. You're taking a whole bunch at once and sampling everything. Notice how here with clustering, we are taking a whole bunch at once. And if I say, go to a classroom and sample 10 random classrooms and talk to everyone in those classrooms, I've never told you a difference between the classrooms. I'm just saying, take classrooms as whole groups of things and randomly take those classrooms, and those are clusters of students. But if I say talk to, I think we can go this way, forward in time. But if I say, go to majors and take 20 supply chain majors and 18 psychology majors, and I'm doing the breakdown, I'm acknowledging a difference, and I'm not taking all of one major, because that would not be representative. So remember, when you stratify, you always start by acknowledging a difference and then sample the groups according to that difference. When you cluster sample, you are going to have the groups hopefully randomly put into the clusters, and then you're going to randomly take those clusters and sample everyone in the cluster. This, especially right here, this perform a census on the cluster is always a giveaway that is cluster sampling. Whenever you see like, we're going to get information on everyone in that group, 100% cluster sampling right there. Whenever you see that we're talking about acknowledging a difference to start, like if we say on-campus versus off-campus students, boom, that's stratified, because we're not going to take all on-campus students. That you could cluster sample that way, but that would not be representative. We're going to say, let's take maybe 80% off-campus students, 20% on. We're going to do it by the ratio that is representative to the population. These are some of the hardest ones right here. And multi-stage can go about 1 million ways, more than 1 million. It can go infinite ways. When it comes to multi-stage sampling right here, you could say, let's go to the Coca-Cola factory and let's take every fifth pack of Coca-Cola cans, 12 packs of cans. Every fifth pack of Coca-Cola cans, like 12 pack, would be a cluster done in a systematic way. We could say, let's go to the Coca-Cola factory and take a certain percentage of 12 packs of regular, a certain percentage of 12 packs of diet. And now the 12 packs are the clusters. And by saying, let's take a percentage of them for each group, we're stratifying, because we've acknowledged the difference by saying we need to take diet and regular, but we're going to take 12 packs. The 12 packs are the clusters, and acknowledging the difference between diet and regular is stratifying, saying we need 80% diet, 12 packs, or 80% regular, 12 packs, and 20% diet, 12 packs. There's about 1 million ways, more than 1 million ways this could go, but listen for those types and remember your sampling methods. Last but not least, we have the sampling biases right here. When it comes to non-response bias, this is kind of the inverse of voluntary bias. These are all bad things. Non-response bias is going to be when people elect not to respond to your questions. So a lot of times controversial questions are going to be non-response bias. You might call someone up on the phone and they hear what your survey's about and they say, yeah, I don't want to take part in that. So these are when the people who don't respond, or the things we don't get information from, differ in the ways than those who do respond. So this would elicit non-response bias. And just think about what it sounds. These things are not responding, and thus this puts a bias into our survey. Next, we have undercoverage bias. When it comes to undercoverage bias, these are still bad, so maybe I'll still use the light red right there, the pink, to say that these are bad right here. We have when we leave out a certain group or voice in our survey, and thus it is not representative. So if we went to the Coca-Cola factory and we only took regular Coca-Cola, how would we know if the Diet Coca-Cola is doing well? We would undercover it. So if I say, go down to campus and go to freshman intro classes and talk to them about what they think about campus, you'd say, Brian, that undercovers other groups of students who are not freshmen, because I'm not going to have access to those students. So just talking to freshmen, which of course we should get their viewpoints, is going to undercover the other class levels of students, and we would not have access to them. So undercoverage means leaving out a certain group or voice unless you do not get a representative survey. Response bias is also bad. When we have response bias, the way the question is worded or the actions of the person giving the question can elicit a certain response. Hence, the bias is in the response. Just think response bias. The bias is in the response. So we think about instances of this where the question is worded in such a way like, do you think it's fair that an 18-year-old can get married, drive a car, go to war, but can't buy a beer? Do you think we should change the drinking age to 18? And thus, do you think we should change? And it doesn't matter whether you agree with that or not. The problem there with the question is the response bias elicited by the way the question is worded, because the question is trying to push people. Someone said, yeah, I think that's fair, or I'm fine with that. But the question's pushing you in a certain way to elicit a response. And that will not then be representative of the views of the population, because we're kind of pushing people towards a bias, maybe towards how we want it to be answered. And everything right here, we've done a very, very kind of short chapter, at least in terms of the idea of what's possible via sampling. If you've ever taken a course on sampling, then you know that there is a lot to consider, and proper sampling is super important to getting good statistics to understand the key characteristics about the populations that we call parameters. And with that, under 20 minutes, whole chapter done, every topic talked about. Keep working hard. We're going to challenge Davie504. He's doing speed runs of base these days. So Davie504, if you want to do some stat speed runs, I was invited.